Hey there, welcome back for another chemistry lesson. If you did not watch part 1 about types of bonds, chemical formulas, and compounds, please go back and watch that first. I'm going to post that way, wherever. I'm going to put it in the cards. Go click the link and go and watch part 1, please. We're going to continue our discussion about the types of bonds and chemical formulas and compounds. So let's talk about elements and compounds first. So elements can either be atomic, like you see them as a single atom, or they can be molecular, where they don't appear as a single atom. And then our compounds are also divided up between molecular compounds and ionic compounds. So let's get a little deeper into that. So atomic elements exist in nature as single atoms. Most elements fall into this category because most elements are metals, and metals exist as individual atoms a lot of times. Molecular elements are elements that cannot exist in nature as single atoms. The reason for this is they are typically unstable when they exist that way. So they will instead exist as molecules of 2 or more of those atoms bonded together. There are 7 diatomic elements, which are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. I'm going to show you on the next slide about that. But there are also 2 other elements that exist as molecules that are not just 2 of them, which is phosphorus and sulfur. Phosphorus appears as P4 in nature and sulfur as S8 in nature. So the reason I said I would get to this in a minute, there are 7 diatomic elements. They make a number 7 up here in the corner, plus hydrogen. So you need to remember hydrogen plus this 7 in the top right hand corner. And then inside of that 7, you have another little 7. I don't know why I said it like that. It's just fun. That is our polyatomic molecules. Now, our compounds, again, remember compounds are either going to be molecular or ionic. Our molecular compounds are composed usually of 2 or more covalently bonded nonmetals. The basic unit for a molecular compound is a molecule that is composed of the constituent atoms. I feel like this sounds like it's common sense, but give me a second and we'll get to ionic compounds and you'll see why I have to spell this out. Water is made up of molecules of H2O. So it's H2O, 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 etc. Dry ice is just solid carbon dioxide, so it's CO2 molecules. And then propane, which is what we use for grills, is composed of C3H8 molecules. So individual groups that have 3 C's and 8 H's. Ionic compounds, on the other hand, are composed of cations and anions, usually metal and nonmetal, although there are some polyatomic ions. We'll talk about that later in the course. But we have ionic bonds is the point. And the thing about ionic bonds is that they are not directional. It is an electrostatic interaction. So we have positive and negative charges that are attracted to each other. It doesn't have to happen this way. It could happen this way, or like at a weird angle, whatever. So because it is not really directional, what we end up with is we don't ever see discrete, like for NaCl. It's not here's a sodium chloride and here's a sodium chloride and here's a sodium chloride like it is with molecules. That's the ratio in which we see them. So the basic unit of an ionic compound, the molecule, so to speak, of the ionic compounds is a formula unit, not a molecular, or not a molecule like it is with molecular compounds. So here we see an individual propane. Here you're pretty much never going to see just an NaCl floating around. It's going to occur in this big chunk because that's how it exists. And finally, I want to talk to you about polyatomic ions, which I mentioned just a minute ago. So many common ionic compounds, there are a lot of ionic compounds that are a metal and a nonmetal. However, there are also a whole lot of ionic compounds that are a metal and then a group of nonmetals. So there are groups of nonmetals that exist where the nonmetals are covalently bonded to each other, but that group itself contains an overall charge due to excess electrons. So this group of charged species is called a polyatomic ion. So here's some examples. NaNO3, this is sodium nitrate. We've got sodium, but then I have, instead of the N being charged or the O being charged, the NO3 group has a negative charge. So NO3 minus is your polyatomic ion. So let's think about this again. The name polyatomic, poly meaning many, atomic meaning atoms. So these are ions with many atoms in there. So this ion has many atoms. This ion has many atoms. We've got calcium and then your carbonate here. And then magnesium chlorate. We've got Mg. And then we have 2 chlorate ions here. So magnesium is made up, it's made up of magnesium and chlorate ions.